Okay, let us to start the class, and just to make a quick review what we have done in the previous class. The last part we have done it in the previous class, that how we can differentiate the complex functions. And we said that to find to show that the function f is the complex function f is differentiable at the point z naught if the limit of f of z naught plus delta z minus f of z naught by delta z, where delta z goes to 0, is exist. But when we discuss this limit, we have to make sure that we have the limit is exist whatever the path of delta z is, because as you know, the domain of the complex number, it will be the pairwise. This is the point z naught, which is equal x naught y naught with coordinates. That means to make sure the limit is exist, I have to show that whatever the path is to approach the point z naught, then it should be the limit is exist and is equal for all along all the paths. We have done the rules and some examples, just a direct substitution for the rules, and let us to show that to do the next two examples. The example says that so that the function delta z is equal f of z is equal z to the power z conjugate is not differentiable at any point z. To show is not differentiable, that means I have to show that the limit of the derivative does not exist, which is enough to show that I have two different paths with two different limits. First of all, I have to calculate delta w. هلا delta w عبارة عن f of z plus delta z minus f of z. هلا f of z plus delta z is equal what? Z plus delta z, all of them conjugate, minus f of z, which is z conjugate. But we know from the rules of the conjugate that the conjugate can be distributed in addition, subtraction, and multiplication. So that becomes z conjugate plus delta z conjugate minus z conjugate, which is equal delta z conjugate. الآن f prime at the number z, or any number z, is equal a limit of delta w على delta z, where delta z goes to 0, which is here. This is delta w, which is equal the limit of delta z conjugate divided by delta z, where delta z goes to 0. طيب الآن delta z is equal what? Here. Delta z is equal delta x plus I delta y. Delta z conjugate is equal delta x minus I fi delta y. So this limit here becomes that the limit of delta z conjugate, which is delta x minus I fi delta y على delta x زائد I fi delta y, where delta x, delta y should goes to 0, 0. Now I have to check different paths. Along the path delta y is equal 0, and along the path delta x is equal 0. If we take here الآن along the path نقول along the path delta y is equal 0, this limit becomes a limit. Replace now delta y by 0, becomes delta x minus 0 على delta x plus 0, where delta x goes to 0, which is equal 1. A limit of 1, which is 1. This is along the path delta y is equal 0. الآن along the path delta x is equal 0, this limit becomes the limit of 0 minus I في delta y. Now replace delta x by 0. 0 plus I delta y, where delta y goes to 0, which is equal to the limit of minus 1, which is 1. That means the limit does not exist. So it is not differentiable at any complex numbers.
Doctor, limit of minus 1 will be minus 1 or 1?
Minus 1, thanks. Of course, this is when delta y goes to 0, because it's a constant. Any question for this example? Right. Let us to see the next one. Show that the function f of z is equal modulus z square is differentiable everywhere in the complex number. Now I have to find delta w and to see what's the limit there. الآن نشوفوا كيف. delta w it will be عبارة عن f of z زائد delta z minus f of z, which is equal modulus ل z زائد delta z square minus modulus z square. الآن we know that here, but we know that z times z conjugate is equal modulus z square, which is equal x square plus y square. So here, just to find out delta w, this is becomes z زائد delta z times z زائد delta z, all of them conjugate. هلا modulus z square is equal z times z conjugate, which is here is equal z زائد delta z times z conjugate plus delta z conjugate minus z times z conjugate. هلا multiply and simplify. Z times z conjugate, z times z conjugate plus z times delta z conjugate plus delta z times z conjugate. هلا delta z times delta z conjugate plus delta z times delta z conjugate minus z times z conjugate. الآن z times z conjugate minus بيروح معنا. Okay. بيبقى معي الآن. Then the left over for delta w it will be now z times delta z conjugate plus delta z times delta z conjugate. Delta z times delta z conjugate and plus delta z times z conjugate. This is delta w. Now take a limit. هلا delta w لdelta w على by delta z, where delta z approach to 0 is equal to limit. This is delta w, where delta z approach to 0. Z delta z conjugate plus delta z times delta z, all of them conjugate, plus delta z times z conjugate. You will see that you can take the division كالتالي. This becomes the limit z times delta z conjugate divided by delta z plus delta z divided by delta z بيبقى معنا هون delta z conjugate plus z conjugate. Here when delta z goes to 0. الآن when delta z goes to 0, when delta z goes to 0, here I have to take different path for this part. معنا الآن if z is equal 0 or if z is not equal 0. Number one, if the path z is equal 0, that means f prime, this is f prime of z, of course, f prime of z becomes 0, which is the limit here. 0 times delta z conjugate على delta z plus 0 conjugate, because delta z, plus 0 conjugate, which is equal finally how much? 0. But if delta z is not equal 0, if delta z شو اللي حصل معي. Now a second case, if z is not equal 0, this becomes f prime of z. It becomes the limit of this one in the blue color. Z times delta z conjugate على delta z plus delta الآن when delta z of course here goes to 0, it becomes 0 conjugate plus z conjugate. This is 0. Then because delta z goes to 0, delta z conjugate will goes to 0 also. And you will notice that we have done this one from previous example. This limit does not exist. So f prime of z is undefined. For z not equal 0. But from the first case, number one, it is differentiable at 0. So when he say find the points at which the function is differentiable, that means the function f, so f of z, it will be differentiable at z is equal 0 only. Any question here? It's a simple calculation, but just when you find the limit, you have to.
Doctor, can you repeat the first case? Why did we let z equal 0?
Here I have to take different path. If the complex number z is equal 0, here we are looking to see where the function is differentiable. If the complex number z is equal 0 here, then f prime exists because the limit is equal 0. But if the complex number z is located somewhere here, not equal 0, then the function is not differentiable there because the limit does not exist.
Then, doctor, we plugged in z equals 0. How did like
Plugged in here, z is equal 0, here z equals 0. 0 times this one, 0. Or this one, 0 also, z conjugate. الآن delta z goes to 0, that delta z conjugate. When delta z goes to 0, the delta z conjugate also is equal 0. So the total limit will become 0. Any question? Any more question here? Okay, let us to go to see just here just the definitions with some simple examples, just to know the definitions only. What's the meaning analytic function? What's the meaning of analytic function? Here is the class of function that is of a great importance whose members satisfy even more severe requirement. These functions are called analytic functions. What's the analytic function is? If the complex number f of z is called or said to be analytic at the point z naught, if it is differentiable at z naught, and at every point in the same neighborhood of z naught, which means that this is the number z naught. If the function f is differentiable at z naught, and at every neighborhood you will take it around z naught, also the function is differentiable there. Also the function is differentiable there. At every, when we say at every point in the same neighborhood of z point, I mean any number here inside this neighborhood, you will the function should be differentiable there. So that means the function f is called analytic function. Of course, analytic at the point z naught, because this is the center of my neighborhood. الآن الاناليتيك domain, الفانكشن بيكون analytic at a domain D if it is analytic at every point in that D. I mean here more general definition, not just a point, at a point, analytic not a point, at a point, but analytic in a domain D. الآن what the entire function means? The entire function is if the function is analytic at every point z, then it is called analytic function. If it is analytic function at every point z in the complex number, then it is called entire function. I mean entire function here, it means analytic at the whole complex numbers, which is equivalent means what? Differentiable at the whole complex numbers here, or on differentiable on the complex, in the set of all complex numbers. For example, polynomial p is differentiable everywhere. Since it is differentiable everywhere, so it is analytic everywhere in the domain. Therefore, it is entire function. Therefore, it is entire function. What about the rational function? F of z is equal P of z divided by Q of z. Both of them are polynomials. This is a rational function. This will be analytic on the set of all complex number except zeros of q of z, zeros of the denominator. Why? Because numerator and denominator are polynomials, so it is analytic or entire function everywhere, but except the zeros of the denominator, because the function itself is not defined at the zeros of the denominator, because anything divided by zero it is something undefined. الآن خلينا نشوف هذا مثلا بيقول لي find the points at which the function f of z is equal to z square is analytic function. First of all, have a look. The function f of z, it is polynomial. إذا الفانكشن f of z, it is differentiable everywhere. وبالتالي الفانكشن f of z is analytic on the whole complex number, which means that the function f of z is entire function. طيب, the next question, he said find the point at which the function is analytic. Here the function is rational function, so I have to avoid the zeros of the denominator. And the function f of z is rational function. بمعنى آخر الفانكشن f of z will be analytic on the complex number except the zeros of the denominator, which is z squared plus 9 is equal 0. And let us to solve it here. When we say z squared plus 9 is equal 0, that means z squared is equal minus 9. So z is equal square root of minus 9, which is equal positive negative square root of I square root of 9, which is equal positive negative 3i. So that means the function f of z analytic on the set of all complex number except positive negative 3i, because it's the zeros of the denominator. طيب نشوف f of z is equal absolute z square. Remember this function we just discussed it in a previous example. Absolute z square. We said that this function is just differentiable only at z is equal 0. So does this function is analytic? Does this function is analytic at z is equal 0? شوفوا here, the function f of z absolute z square, this one is differentiable on z is equal 0 only. So it is impossible to find a neighborhood of z is equal 0 such that the function f of z is differentiable at all points in this neighborhood. I mean, because it is just only differentiable at this 0, I cannot find a neighborhood around 0 where the function is differentiable everywhere inside this neighborhood, which means the function f of z is equal z absolute z square is not analytic at any point in the complex number. It is not analytic at any point in the complex number. Any question? Any question here? طيب خلينا نروح الآن to the definition of harmonic function. A real valued function phi of xy of two variables. I mean, this function is a function of two variables, x and y. This is a real valid function that has continuous first and second order partial derivative in a domain D, and satisfy this Laplace equation is called a harmonic function on that domain D. I mean, a function of two variables x, y is called harmonic function. Harmonic function if the first and the second partial order derivative of this function, all of them are continuous on a specific domain D, and in the same time satisfying this equation, d square phi by dx square plus d square phi by the dy square partially, all of them, to be equal 0. What do you mean by first and second order partial derivative? It means d phi by dx, d phi by dy, d phi d square phi by dx square, and d square phi by dy square equal are continuous on a specific domain D. This is what we mean by partial derivatives. Also, if they are continuous, all of these four derivatives, and satisfying this equation, this is called harmonic. خلينا نشوف الآن this function. Show that the function txy e minus y sine x is harmonic throughout the xy plane. I have to check t sub x, t sub y, t sub x, t sub y. And those partial first and second partial derivatives to see are they continuous on the xy plane or not. If it is, then I have to check the Laplace equation. And when we say t sub x, it means I have to assume x is the variable and y is a constant. So that means is equal e to the power minus y times cosine x. T sub y, I have to respect y is the variable, x is a constant. So sine x is a constant. Minus e minus y sine x. Txx derive the first t sub x another time with respect x. So that becomes txx minus e minus y, the derivative of cosine is minus sine. Tyy, that becomes e to the power minus y sin الواي. الآن all of these derivatives are continuous on r square. Why? Because exponential continuous, cosine continuous, their multiplication continuous, exponential continuous, sine continuous, their multiplication also continuous. So all of them are continuous. Now you have to go to check the second condition, which is the Laplace. Now, t sub xx plus t sub yy is equal. How much is t sub xx? Minus e minus y في sin x. T sub yy e to the power minus y sin y, and that is equal 0. So the function t is harmonic on r square.
Doctor, isn't sin x not y?
Sorry? Yes, here x, thanks. Here the same. Thank you. So it is a harmonic function. Satisfied the two conditions. Type. Is it the function uxy is equal x square plus y square harmonic or not harmonic in any domain in the xy plane? Let us to check. U sub x is equal to x, u sub xx is equal to, u sub y is equal to y, u sub yy is equal to. Those are continuous on r square, but u sub xx plus u sub yy is equal 2 plus 2, which is equal 4, which is not equal 0. So not harmonic in any domain. In r square. Any question here? There is a theorem here for the harmonic function, says that if the function f of z is analytic in a domain D, then it is real part is a harmonic in D, and it is also imaginary part harmonic in D. If the function f of z, which contains real plus imaginary, is analytic in a specific domain, then the real part harmonic, also the imaginary part will be harmonic. Let us to check this one. The function f of z is equal z square, which is x square minus y square plus I times 2xy. This is entire function because it is, this one is differentiable everywhere, analytic everywhere in the complex number, so it is entire function. And the function u sub x, it is the real part, which is this one, x square minus y square. And the imaginary part, 2xy. Then those two functions, the real one and the imaginary one, should be harmonic in any domain of the complex number. Let us to check, is that correct? When we say that uxy is equal x square minus y square, u sub x, it is 2x, u sub x, it is 2, u sub y minus 2y, u sub y, it is minus 2. All of these derivatives are continuous on r square. Also, u sub x plus u sub y is equal to minus 2, which is 0. So, harmonic in r square. Harmonic in r square. الآن check the second one. Vxy, it is 2xy. Vx, it is 2y. V sub x, it is 0. V sub y, it is 2x. V sub y, it is also 0. All of these are continuous on r square. Also, u sub x plus u sub y is equal 0 plus 0, which is 0. So harmonic in r square. Any question up to now? Any question? Do we have any question? So this section is done. This section was quite long. Now we will go to the next section, which is very short section. We still have two sections, this section and the next one. Both of those two sections are very short, and we will finish inshallah on Tuesday this chapter. So next week we will have a quiz, and I will send you the homework also. What we are going to learn in this section regarding the complex, we will go to learn the exponential and the logarithmic functions, len functions, natural logarithm, how we can define it for complex numbers. Also, we will check the properties of the exponential and the properties of logarithmic function, and the complex power, compute complex power of complex numbers. طيب الآن start from the beginning. Complex exponential. We already learned the complex exponential before in section 17.3. هلا e to the power z. When we have the complex number z is equal x plus iy, so e to the power z is equal e to the power x plus iy, which is ex cosine plus iex sine. We already discussed this definition before. الآن, because this one here basically is equal e to the power x times cosine y plus I في sine y. This is called the complex exponential function. هلا الدومين of e to the power z is the set of all complex numbers. The domain of the exponential function is the set of all complex numbers. الآن Some examples. When we say that evaluate e to the power 1.7 plus 4.2i, it's very simple. This is equal e to the power 1.7 plus 4.2i. This is equal e to the power 1.7 times cosine ال 4.2 I في sine ال 4.2. Then I have to do the calculation by using the calculator, which is approximately e to the power 1.7, approximately 5.4739. Cosine ال 4.3 minus 0.49026. Here sine also is equal minus I times 0.87158. E to the power minus 2 pi plus pi I, the same procedure here. نفس الطريقة 2 pi plus pi I is equal e to the power minus 2 pi في cosine الباي زائد I في sine الباي, which is equal 0.00187 times cosine الباي minus 1 minus 1 plus sine الباي 0. I في 0, which is minus 0.00187. It's just a matter of simple calculations. الآن the properties of exponential function. E to the power z will not equal 0 for any complex number. We have the same property in real. E to the power any real number is not equal 0. So again, e to the power any complex number will not be equal 0. طيب. الآن the exponential function e to the power z is entire, and it is a derivative given by d by dz is equal e to the power z, which is the same derivative of exponential in real numbers. الآن if you have two complex numbers z1 and z2, e to the power z1 times e to the power z2, the base here are unified. So you just added the powers, e to the power z1 plus z2. Also, e to the power z1 divided by e to the power z2 is equal e to the power z1 minus z2. We have the same properties here for the real numbers. Now let us proceed to find the derivatives here. Will you find the derivatives for the following functions? F prime of z here. Here I have the function iz to the power 4 times e to the power z. Here we have a product. So we have to apply the product rule for the derivative, which is 4iz to the power 3 e to the power z plus I في z to the power 4 في e, the derivative of e to the power z is e to the power z. واللي هنا بيعني لي ماذا؟ That becomes I z to the power 3 e to the power z times 4 plus z. Part B, g prime of z, I have to derive as a normal derivative, but I have to use the chain rule, which is the derivative of this part times the same function. What's the derivative of z square? It is 2z minus iz, minus 1 plus I times z. What's its derivative? It is minus the 1 plus I. Derivative over 3, it is 0. times the same function e to the power z square minus 1 plus I في z plus 3. طيب البيريوديسيتي الفانكشن e to the power z, the exponential function, is periodic with period 2 pi I. What does this mean? That means f of z plus 2 pi I is equal f of z. That's what we mean. Well, this is what I mean here by periodic with period 2 pi. Why? Because f of z plus 2 pi I is equal e to the power z plus 2 pi I, which is equal e to the power z times e to the power 2 pi I, which is equal e to the power z times e to the power 2 pi I عبارة عن مين؟ cosine of 2 pi I في sine 2 pi, which is equal e to the power z times cosine of 2 pi, the same as cosine of 0, which is 1. I times 0, 0, sine of 2 pi is equal 0. So this becomes e to the power. So f of z plus 2 pi I is equal f of z. So it is a periodic with period 2 pi I. طب is it the function f of z the exponential 1-to-1 function? Just take it here. The function f of z is equal e to the power z is not 1-to-1. ليش؟ Since ال1 بده يساوي e to the power 2 pi I, which is also equal e to the power 4 pi I, which is equal e to the power 6 pi I. So you have two different values, they have the same image. So f of 2 pi I is equal 1, which is equal f of 4 pi I. So not 1-to-1 function. مش اقتران واحد لواحد. This is just what we have to know about the exponential. Now let us go to the logarithm. We still enough time to finish it, inshallah. The logarithmic functions. Logarithm functions. الآن, in calculus 1, when we studied ln, what's the meaning ln x in calculus 1? Who can tell me what's the meaning ln x in calculus? Ln x, what do you mean by ln x?
log e.
In calculus, if we have e to the power x is equal y, that implies ln y is equal x. I mean, ln is the inverse function of the exponential in calculus. Also, the exponential is the inverse of ln. الآن, e to the power z will be defined from the set of all complex number it is domain to a range complex number except 0, because I told you before here that E of Z cannot be equal 0. الآن اللوغاريتم is the reverse of logarithm in complex is the reverse of or the inverse of the exponential. I mean, ln of Z in complex number becomes now from complex except 0 to the complex number. But what's the meaning of logarithm of complex numbers? Ln of Z of any complex number is equal logarithm of absolute Z with base E plus I times the argument of Z. But here is the small argument, not the principal argument, which is equal here, if you would like to write it in general, log absolute Z with base E plus I phi theta plus 2n pi. This is called the complex logarithm, where n is equal 0, 1, 2, 3, and so on. Therefore, ln of any complex number is not a unique value, because each time you will replace the value of n here, you will get another value. طيب خلينا نشوفهم. بيقول لي find the values of ln absolute ln minus 2 sorry. طيب ln of the complex number minus 2 is equal logarithm absolute of minus 2 with base E plus I في الارجيومنت ل minus 2. الآن where is the minus 2 here located as a complex number? This is one here, minus 2. This is pi. So the argument is equal ln logarithm of 2 with base E plus I phi pi plus 2 and pi. 1 is equal 0 minus plus 1, 0 minus plus 2, and so on. Here you have to use the calculator to calculate logarithm 2 with base E, which is here is equal approximately 0.69315 plus I times pi times 1 plus 2 and leave it as it is in this way. الآن number 2 or part B of the same example. Ln of I is equal logarithm absolute I with base E plus I في الارجيومنت للI. I, where is it I? This is I. Here it means the argument pi over 2. How much is the absolute value of I? It is 1. Plus I phi pi over 2 plus 2 and pi. هلا logarithm ال1 with base E is equal 0. So this one here becomes is equal I phi pi over 2 plus 2 and pi. This is logarithm of I. طيب part C. len of -1 minus I is equal log absolute -1 minus I with base E I في الارجيومنت of -1 minus I which is equal. هلا الابسوليوت ل -1 minus I it is the square root of 2 with base E plus I times -1 minus I it becomes it is argument عبارة عن -3 pi over 4 -1 من ال x minus I it will be here somewhere. So الارجيومنت the principal argument اللي هي -3 pi over 4 because I have to go clockwise -3 pi over 4 or 5 pi over 4. You can take any one of those. -3 pi over 4 plus 2 and pi. Budget clear this example واضح المثال هذا؟
Doctor, here how to get the square root of 2?
Log square root of 2. From where you got it. هلا here. الابسوليوت ل -1 minus I بدي يساوي square root of -1 square plus -1 square واللي هي square root of 1 plus 1 square root of 2.
Okay.
All right. Any question up to now؟ لحد الآن في أي استفسار أو سؤال؟ طب نشوف بعض المسائل. بيقول لي find all values of z such that e to the power z is equal square root of 3 plus I. طيب. First of all, how we can solve this one? When we say that e to the power z is equal square root of 3 plus I, when you take ln for both sides becomes ln e to the power z بتساوي ln of square root of 3 plus I. Ln e to the power z it is z. So z it becomes ln of square root of 3 plus I, which is equal log absolute less square root of 3 plus I with base e plus I times the argument of square root of 3 plus I. And where is this square root of 3 plus I located? Here. Square root of 3 من x بده يكون somewhere here واللي هو more than 1 وهي بده يكون عندي from I square root of 3 plus I. Theta here is equal pi over 6. طيب الآن how much is the absolute for square root of 3 plus I? So argument للابسوليوت فاليو بصير عندنا square root of 3 square واللي هي 3 plus 1 square which is 1 square root of 4 بيعطيني 2 with base E plus I في باي على 6 plus 2 and pi. Values of n is equal 0 minus a plus 1 and so on. أشهد أن لا إله إلا الله وأشهد أن محمدا رسول الله. طيب e to the power z is equal minus 1. We never saw such equation in calculus because e to the power exponential all the time positive, but here you can solve it in complex. The same procedure here. When we say that e to the power z is equal minus 1 implies z is equal ln of minus 1. And we never saw ln of minus 1 in real numbers, I mean in calculus. This one becomes here عبارة عن logarithm absolute ل minus 1 with base e I في الargument of minus 1 ويساوي log ال1 with base e. Where is minus 1 in? This is minus 1. It is argument pi. I في pi plus 2 and pi n is equal 0 minus a plus 1. Log L1 is equal 0, so that becomes I times pi plus 2 and pi, where n 0 minus plus 1 minus plus 2 and so on. Okay, any question here? Here just this section and the next section is just a matter of calculation only. يعني المفاهيم كلها عبارة عن حسابات. طيب نشوف if we have z1 and z2 are non-zero complex numbers, then ln of z1 times z2 is equal ln z1 plus z2, which is the same as the property of ln in calculus. Ln of z1 divided by z2 is equal ln of z1 minus ln of z2. طيب, if you notice here, when we defined ln, we said small argument. Small argument, it means theta plus 2 and pi. But we will define, and we know that there is a principal argument. So for such a principal argument, capital A, we will define a principal logarithm of the complex number z. The principal logarithm of the complex number z is equal logarithm absolute z with base e plus I times the principal argument of z. This is called the principal argument of the complex number z. Remember the principal argument of z, it should be belong to minus pi with pi, closed from the side of pi and open side from the minus pi. طيب نشوف some examples هون. We'll nearly finish this section inshallah. We'll find the values of a principal logarithm of minus 2. هلا the principal logarithm of minus 2 is equal logarithm absolute minus base e plus I في the principal argument of minus 2. Where is minus 2? This is minus 2 here. So you will go, this is the principal argument, which is pi. So that becomes logarithm of 2 with the base e plus I phi pi. Now you just calculate this one, 0.69315 plus I phi pi. Number 2, the principal argument for I. The principal logarithm, sorry. The principal logarithm for I is equal logarithm for absolute I with the base e plus I for the principal argument for I. And that is equal logarithm of 1 with base e plus I. What's the principal argument for I? Pi over 2. So that's equal 0 plus I phi pi over 2, which is I pi over 2. The last one, part C. The principal for minus 1 minus I. The principal logarithm for minus 1 minus I is equal logarithm absolute minus 1 minus I with base e. I per the principal argument of minus 1 minus I. Where is the principal argument here? This is the location of minus 1 minus I, so this complex number here. Look here, have a look here. If we go this direction, it will be more than pi. I mean the counterclockwise. But I have to go clockwise, it is minus 3 pi over 4. And we just calculated here عبارة عن logarithm square root of 2 with base e plus I في minus 3 pi over 4. طيب نشوف النكست ثيرم. Theorem for the analytic of the principal argument, principal logarithm, sorry. The function principal logarithm of z is analytic function in the domain D, where z is equal r e to the power I theta. R is greater than 0 or theta between minus pi to pi. And its derivative is given by d by dz for principal logarithm z is equal 1 by z. الآن where is r is greater than 0? R e to the power I theta. I mean the polar form with theta between minus pi to pi. I mean pi is not included. This is theta is equal pi. I mean have a look, there is no equality at the pi or minus pi, which means that it is analytic at every point here except the points in this blue color, because here theta is equal pi. If you go the counterclockwise, if you go clockwise, theta is equal minus pi, and it is not included here. طيب. Which means here it is the function principal logarithm z is analytic everywhere except those points located on this blue color, I mean, which is the negative real axis for the x-axis. طيب الآن نشوف exponential. Do we have a time? We need just 5 minutes. I was running late. I was waiting you 5 minutes, so I have to take those 5 minutes now. If C is any complex number and Z also is any complex number not equal 0, yes?
Doctor, sorry to interrupt you, but I have a lab at 3:30. I have to leave my home.
Okay, you can go. What's your name?
Irzam.
All right. All right,
So,
okay. Let us to stop here. Oh, okay, okay. Let us to stop here and to take the attendance, please. Take the attendance and I will stop here.
thank you very much.
Thank you. Can you enter the attendance code, and we will finish this part with the next section, inshallah ta'ala, on Tuesday.